Okay, so I just left off where we're going to do the example on 449, and it says find the linear speed of the tips of the blades in example 8. So let's look at example 8 and see what it has to say. So we've got a wind machine, also known as a windmill, used to generate electricity, has blades that are 10 feet in length. So that sounds like we've got a radius going on. The propeller is rotating at 4 revolutions per second. Find the linear speed in feet per second of the tips of the blade. So in our formula, what stuck out to me really plainly is we have the radius and we're looking for the linear speed or linear velocity. So what I'm going to do, and what I always do with word problems, is I go ahead and write down that I need to find velocity, and also I know my radius, it's 10 feet. Well, that's not near enough to help us out. Yeah, we can plug in radius here, but we also need theta, and we need to know, we need to get our unit of time from somewhere. So how can we figure out what theta is? There is something over here about rotating at 4 revolutions per second. Okay, so there's our time per second. 4 revolutions. Is there some way, this is me thinking to myself, is there some way that we can change 4 revolutions into radians? Well, think, 1 revolution we know is 360 degrees. And we know 360 degrees is the same as 2 pi. So in other words, 1 revolution is 2 pi radians. So we can convert 4 revolutions to radians. Let's do that. So we're going to take 4 revolutions per 1 second. That's really fast. Times, and we're going to convert this to radians. So in order to get rid of the revolutions, we need 1 revolution down here. Those will cancel. And 1 revolution is equal to 2 pi radians. And if that doesn't make sense, think 1 revolution, 1 circle, is 360 degrees. And 360 degrees, if you convert that to radians, is 2 pi. That's where I got this number. So now we can just multiply across the top. We get 8 pi over 1 second. So we have 8 pi radians per second. Now we have our radius, we have our theta, and we have our unit of time. So we can plug all those in, and we need to do 10 times 8 pi over 1 second. That's 80 pi per second. You can also approximate that. Grab a calculator. And it's 251.32 radians per second. And there you have it. That's the linear speed. Hold on a second. Feet per second. Oops. That's feet. All the way through, that was feet. Because up here, I forgot that this is 10 feet. That's where our units come from. So 10 feet times 8 pi. So we've got 251.32 feet per second. That is how quickly the tips of the blade is moving around here. That's how many feet the distance it goes per second. Okay, so now let's talk about angular velocity. Angular velocity, again, is revolutions per time, and we actually have to do it in radians. Here is a formal definition. It's pretty much exactly the same as up here, except I said the measure of the angular displacement of a particle per unit time. Remember, it has to do with the angle itself. We don't really care how much, I'm moving my finger down here. We don't really care how much distance it went. We just care how big an angle it has. So here's our formula. It's a little bit simpler. If a point is in motion on a circle, its angular speed is the angle over time. That's it. And the important part is theta is in radians. So our example over here, a tire completes 6 full revolutions per second. Determine its angular velocity. Well, we have revolutions per second, but what we need is radians per second. So what we're going to do to find theta is we're going to convert 6 revs per 1 second. We're going to convert it to radians. So we need revolutions down below so that these will cancel. And 1 revolution, hopefully you know, is equal to 2 pi radians. And now you just multiply across the top and across the bottom. So we've got 2 pi radians per second. And now, basically, the second is your time unit, and so that's really your answer. 12 pi radians per second. You can approximate that and get 37.70 radians per second. And remember, radians are the invisible unit here. So that's why I'm not writing it down. If it really bothers you, though, you can write radians per second. And that's it. Now, one thing that I would advise you guys is I didn't highlight much of anything here and how it connects to these formulas. But if you want to, I'm going to put a second video up that shows the highlighting in case you want to do that for when you look back at this.